Good morning, everybody. I'm Ed from Offchain Labs, and I'm here to talk about what we can do at layer 2 to make Ethereum better and grow the Ethereum space. But let me start by talking about why layer 2. Why is it that we're focused on layer 2 as the place to innovate and grow Ethereum? This really goes back to Vitalik's post quite long ago on the roll-up-centric roadmap. This is the idea that Ethereum would seek to grow, especially seek to grow at scale, not by trying to build a monolithic protocol that does everything, but instead by focusing on allowing layer 2 and eventually later layer 3 and above protocols to grow by innovation and to grow by horizontal scaling. And this, to my mind, is one of the smartest things that Vitalik ever did, which is really saying something. I think it's a brilliant move, and it's one of the things that has set Ethereum apart so far and has laid the groundwork for future success. Why is this such a good idea? Well, one of the reasons it's a good idea is that it follows the approach that was taken by the internet. And the internet, of course, is by far the most successful, open, credibly neutral protocol that has ever existed. Layering in the internet was one of the keys to success. The internet swept the field and destroyed all of the monolithic protocols that were proposed as alternatives, even the ones that came before it. And the reason for that is that by being layered, the internet could have each layer focus on doing one thing extremely well, and it could allow innovation at the higher levels of the stack. Because the layers plugged together, you could pick a best-in-class solution at each layer, and that could emerge naturally from the activity of people in the market and people innovating, rather than trying to build out everything in a centrally controlled way. That's been hugely successful for the internet, and I'd argue it's been successful for Ethereum and has laid the groundwork for future success. So how's it going, layer 2 and layer 3? Well, if you look at the throughput of the layer 2 and layer 3 ecosystem in Ethereum, measured versus in units of Ethereums, what you see is that layer 2 and 3 collectively have about 30 times the transactions per second of Ethereum, about 80 times the gas usage, about 40 times the call data, and we have now more than 100 L2 and L3 chains. This is huge success. Ethereum could never have gotten to the size. ETHDenver would not be as large as it is without the growth of L2 and L3 chains to grow the ecosystem. And just to emphasize how much growth has come because of the L2 and L3 ecosystem, here's a bar graph that shows the gas usage at different layers of the Ethereum stack. What you can see is that L1 accounts for only a couple percent. Now, so in other words, almost everything that happens in the Ethereum stack today happens at layer 2 and layer 3. Now that's not to say layer 1 is not important. Layer 1 is the hub for liquidity, and it's this foundation on which the security of layer 2 and layer 3 is built. Just like how there could be no internet without TCP/IP, there could be no Ethereum stack without layer 1. So it is the foundation, it's critically important, but it's not where most of the activity happens anymore. That's why, if we want to grow Ethereum, we need to focus on growing at layer 2 and layer 3, because doubling or tripling or even 10xing the throughput of layer 1 is not going to make a big difference. Okay, so how do we grow Ethereum? I hope I've convinced you that when we do that, we want to be focusing on layers 2 and 3. But I want to talk more generally about what we need to grow Ethereum, what we should be focusing on versus what's just a distraction. So let me tell you first a bunch of things I think we don't need. We don't need silos. We don't need different L2 and L3 stacks that refuse to talk to each other. We don't need exclusive clubs that you have to apply to join, that you need to become a member of and sign away some of your rights to participate in. I don't think that's the way forward either. And we don't need rigged games. We don't need short-term activities which just exist to enrich a few people at the expense of most of the users of the system. And you know what I'm talking about here. What we need is to focus on sustainable growth, growth that's open and welcoming, and that brings more people in and connects more things together, rather than trying to put up fences. So in other words, what we do need is Ethereum alignment. Now, there's been a lot of chatter about Ethereum alignment, a lot of people accusing each other online of being not aligned. I don't want to play that game. I don't think it's productive. What I do want to do is say what, to me, Ethereum alignment means. To me, alignment means making the Ethereum stack faster, cheaper, more reliable, and easier to use for the benefit of users and developers. If we're doing that, then we're Ethereum aligned. And one consequence of this is that we don't have to accuse each other of not being aligned. We can instead just each focus on being as aligned as we can, because every developer, every stack can be pursuing these same goals at the same time. So I want to structure the rest of my time around these themes of faster, cheaper, more reliable, and easier to use. And again, emphasizing that this is for the benefit of users and developers. We're not building a chain for the benefit of infrastructure providers. I love infrastructure providers, but the chain is not for them. It's for the users and developers. Okay, let's start with faster. What do we need to do to make the Ethereum stack faster? There's a bunch of things we can do and should be doing, and let me just rattle off a few of them first. First, we want to have benchmarks. We want to have standardized ways to measure performance and realistic performance, not just what is the largest TPS number you can say without bursting out laughing, but what is a realistic workload, what is a realistic set of transactions on a realistic state size, so that we can actually compare and measure and know how well we're doing. Second, we want faster execution. We want faster virtual machines. We want to execute the EVM faster. We want to introduce new models of execution that are faster, but also compatible and composable with EVM. We want parallelism. We want execution engines that can discover parallelism and exploit it when it's available, but without making developers' lives much more complicated by making them think about parallelism and race conditions and all of that. We want resource pricing that's better so that we can better align incentives of users and developers with the real constraints on node execution. And then finally, we want to work on sharding to get horizontal scaling with less friction. We need to do all of these things. I want to talk about one particular thing that Arbitrum is doing, or a couple particular things that we're doing in the Arbitrum space to make this so. The first of them is Arbitrum Stylus. That is, really focuses on what developers need in a faster ecosystem. You want familiar, standard, battle-tested languages and tools. You want fast execution. And most importantly, you want to be able to write in those languages and execute quickly while having full composability with EVM. That's what Arbitrum Stylus provides you. There's examples here of a few teams who are building with Arbitrum Stylus. Basically, this is a feature that lets you write a smart contract in Rust, C, or C++, compile it, and deploy it directly onto an Arbitrum chain in a way that's fully composable with EVM execution. Not executing in a separate silo, not needing a separate user wallet. Everything just works naturally so that users and developers don't even know whether the contracts they're interacting with are using EVM or Rust, C, or C, C++. The only way they know is that it's much cheaper and faster if you're using Stylus. I also want to talk about horizontal scaling. What that means essentially is instead of having a single L2 or L3 chain, you can have many chains at the same time. And there's been an incredible explosion of different chains. Here's a diagram that shows some of the chains that currently use the Arbitrum technology. There are more using Arbitrum. Of course, there are others using other stacks. There are now well over 100 L2 and L3 chains in the Ethereum ecosystem. And these not only give you growth in the execution capacity and throughput, bring down cost, but also these chains can be customized to meet the needs of particular applications, use cases, or user communities. And that customization is also important. That's key to that approach of layering. One huge advantage of layering is that different people can do different things at layer 2 or layer 3 without needing to lock everyone into a single model or a single configuration. If you want to optimize for fast block times, you can do that. If you want a different economic model, different governance model, you can have that, all while still being part of the Ethereum stack and the Ethereum community. All right, let's talk about cheaper. What's been happening at L2 and L3 to make execution cheaper for users. But it's important when we talk about cheaper to distinguish two notions of cheaper. One is, are we lowering the cost of actually operating the chain? And the other one is just, are we lowering the fees? Because you can lower fees in the short run. Well, execution is expensive, but that's not going to be sustainable. To get a sustainable reduction in fees, you have to start with a reduction in the cost of operation. Because at the end of the day, VC subsidies are only going to last so long. And you're going to be in a situation where long run, fees need to cover costs. Okay, let me give you a great example of how the layered approach has led to a big cost savings in operating the Ethereum stack that's really passed through for users. And that is the onset of data blobs in EIP 4844. So here is a very boring page from Etherscan showing a transaction in which the Arbitrum1 chain posted a bunch of its data. But the important part is this, which I've zoomed in on, that for this particular batch of data from Arbitrum, it was posted at about a 40x cost reduction on Ethereum. Of course, a cost reduction that passed through to users. So how did that happen? Well, this started by thinking about how can we lower the cost for Ethereum validators and nodes of posting all of this data for L2 and L3 chains. And people realized that L2s were posting call data on Ethereum, but Ethereum call data did more than the L2s needed. And so this new idea of blob data, which did just what the L2s needed and was much cheaper for Ethereum nodes to provide. So lower cost for Ethereum validators. That led to lower data fees on Ethereum if you're using data blobs. Those lower data fees on Ethereum led to a lower cost of L2s for posting their data, and that in turn led to lower fees for L2 users. A dramatic reduction in not only in fees, but also in underlying cost. By thinking carefully about what does layer 2 need from layer 1, and how can layer 2 provide what layer 1 provide what layer 2 needs at lower cost. A big win from the layered design approach and from thinking about cost reduction. In addition to things like this, we also need to keep thinking about better pricing for the resources that we use. Fundamentally, all of these chains use gas prices or base fees as a way of slowing down the chain if the mechanism is worried that nodes are going to get overwhelmed. So if we get smarter about data pricing, then the pricer can hit the brakes less aggressively because it can have more confidence that you're not overrunning the nodes. So better pricing means more throughput on the same nodes. Also important not only for lowering cost, but for increasing capacity. Okay, let's talk about how to make the system more reliable. And here I don't have any magic breakthrough research. What I have is a lot of engineers doing a lot of work and people thinking really hard and having the mindset of reliability and high quality software. There's no magic bullet here. This is people working every day to make the stack more reliable. And I'm proud of what Arbitrum has done and what Ethereum has done in that area. Ethereum is sometimes accused of being too careful about reliability and safety. I think Ethereum should wear that accusation proudly, because Ethereum has been reliable, it has been safe, and it has continued to function well for its purposes, partly because the community works and thinks and tests so hard to make it so. So reliability is hard work by everybody. All right, now let me talk about easier to use. Because one of the side effects that we've had as we've gone to this layered approach, layer 2s and layer 3s, horizontal scaling with hundreds of chains, one of the implications of that has been that there's some friction in doing things across chains or moving assets across chains. Of course, a lot of people are working on this problem. But right now, a big part of the easier to use problem is not just people thinking harder about user experience, but also working particularly on how to connect everything. Okay, so here again, I think we can take a page from the internet. The internet, of course, has been hugely successful at getting all kinds of servers and services at different layers of the protocol, all kinds of software products to work together in a really seamless way. So what can we learn? What does interoperation, internet style, look like? And how can we learn from that in trying to get Ethereum to interoperate? Well, internet style interop has a bunch of features that I think we could do well to try to copy. One of them is it focuses on speed. Second is that it's standards-based. There are standard ways of talking about what is an address, who are we talking to, how do we encode the payload at each layer of the protocol. Each layer has its own way of encoding and representing data, but it leaves to higher layers a lot of other decisions that belong there. Internet-style interop is asynchronous. We don't have one node, one service stopping and waiting for another. Instead, we fire off a request to somewhere. When the response comes back, we deal with it when it comes back. Asynchrony is really important in order to get good performance, and it's also really important for reliability because of the next couple bullets. First, next it's fault tolerant. That is, you don't just assume that the service, that the chain, that the node on the other end is going to be there. You don't just assume it's going to be honest, and you don't just assume that it's going to give you an answer that makes any sense at all. Every component of this system is prepared for other components failing, going wonky, going weird, being super slow. And finally, it's security conscious. You don't assume the party on the other end is secure. If you're interacting with some other service, some other chain, you don't assume it's necessarily secure. A user can decide to interact with a particular service or rely on it, but you don't want one service to assume that some other service is secure without thinking really hard about it and without communicating clearly to the users what assumptions you're making. And I think we'd be well advised as we build out interop in the Ethereum space to try to emulate all of these features. Okay, so what does that mean? There are different approaches going on. There's a really active discussion about standardization. The EF ran a really productive interop offsite on Monday across town here in Denver. But I want to talk in particular about what we're doing in the Arbitrum community about interop. And you may have seen a post on Medium recently and a bunch of discussion about the universal intent engine. This is the thing that we're really excited about building out. I want to take a minute about what it means. First of all, this is an intent-based approach to interop. So fundamentally what that means, or actually let me just walk you through a sort of timeline of what the experience, what the journey looks like for a user in this system. So the user journey in this system looks something like this. You have a user over on the left. The user wants to do something. So you might imagine the user has some assets over on chain A. They'd like to move them over onto chain B. Maybe also exchange them to some other asset, but at least move them. So the user then takes an action on the chain where they have the asset, which provides those assets into some escrow contract and provides some parameters. I want to move these to this other place. Here's how much fee I'm willing to pay. Here's how quickly I'd like it to happen, et cetera. All of that is the user's intent. This is what they're requesting from the system. The application or the user's wallet then formats that and puts it into the universal intent feed. That feed publishes the fact that this user wants to do a particular move of assets from one place to another. The user's funds go in escrow. Eventually, some party shows up, some party who's subscribed to that intent feed shows up, says, yes, I'm willing to satisfy that over on the other chain. I'm willing to give the user funds on the other chain. Here's the fee I'll take, assuming that that matches up. And I'll show that provider's intent next. Then there's a cross-chain settlement protocol that executes. The user gets their funds on the destination chain, and their funds are paid out of escrow on the home chain. The beauty of this is that it's flexible, it can be very fast and trustless, and the user experience can be really nice. The user says what they want, and then the rest of the mechanism is handled by their wallet or other service provider. Now, the solver's journey, the party who's providing the other side of this, is pretty similar. They subscribe to the intent feed. They decide they want to bid on this intent. If they're chosen, they put funds into escrow. They participate in the cross-chain settlement protocol. Their funds will be paid from escrow out to the user, and then they'll receive funds on the other chain later, thanks to cross-chain settlement. So that's interop. By doing these things together, we can align the incentives, and we can continue to build out the Ethereum stack. The future of L2 is the future of Ethereum, and as I end every talk with the Arbitrum mantra, your chain, your rules, let's build Ethereum together. Thanks.